Welcome to The Paradox with your attending, Dr. Eric Larson. He is a practicing anesthesiologist and clinical assistant professor at Michigan State University College of Human Medicine. Listen in as he takes you behind the scenes of what practicing medicine in today's ever-changing world is like with another doctor. The Paradox is a fun and accidentally informative show for physicians, patients, or anyone who has ever found themselves in a waiting room.
It's Dr. Eric Larson. Here's with my new friend, Dr. Monica Gandhi. She's a professor of medicine at UC San Francisco, director of the UCSF Gladstone Center for AIDS Research, and medical director of the San Francisco General Hospital HIV Clinic. She earned her MD at Harvard and went to UCSF for residency and fellowship in infectious disease. And she earned her MPH from Berkeley with a focus on epidemiology and biostatistics. Dr. Gandhi, thanks so much for joining the show.
Thank you for having me.
Well, it's a real pleasure. Having someone in California, always the time difference always makes things interesting.
Yes.
And no one ever realized that Michigan's actually in the Eastern time zone. We're actually right on the edge.
Literally, when you just said that, it hit me that I didn't know this. Yes. Thank you for telling me. Yeah.
Right. It's great because in the winter, it stays, or I should say in the summer, it stays light out to about 9:30, almost 10 o'clock in the northern parts of the state. So it's actually great, unless you want to go to drive-in theater, then it's a bad thing. So.
Or sleep.
Or sleep, right. So I think what we'd like to do, since you're infectious disease specialist, you've done lots of interviews with COVID. We're obviously going to talk about COVID-19, but I have a lot of listeners, and let's just pretend I'm an anesthesiologist. I don't know anything about infectious disease and immunology, right? Can you go over some basic terms? So what is a T-cell? What is a B-cell? And what role do they play in the immune response to a viral infection?
Great question. So essentially, those two cells that you just said are the main arms of the immune system. So there are, when you get an infection or when you get a vaccine, it triggers B cells and T cells. And the way to think about B cells is they're the cells that produce antibodies. And we hear a lot about antibodies because we're always talking about antibodies, and they're quite easy to measure. So there's a lot of studies about antibodies. But the second arm of the immune system, T cells, are actually the main and most durable arm of the immune system that fights viruses. And T cells are divided into two flavors. One are called killer cells and one are called helper cells. So, and those are CD8 and CD4 cells respectively. And all of those cells are triggered when you get an infection.
Right. And so the B cells were the ones we're looking at for antibodies, right? Is that pretty much? And then
yes, they're the ones that produce those antibodies.
And then how do you get the durable immune response? Because you will have people who have antibodies for some diseases. They tend to last for your life, and other times they tend to just disappear. But then they can right?
Yes, and actually they should disappear. The way I think of it is, if we had antibodies in our bloodstream for every infection that we've seen, our bloodstream would be like cement. So it would just be so thick with antibodies because they're proteins, and your blood can't contain them. So actually what happens is it's natural for antibodies. It's not a glitch. It's a good thing that our antibodies decrease over time. They wane from the bloodstream itself. But luckily there's essentially always the parent or the progenitor cell, the B cells, that stick around. And if they see the infection again, they can be revved up to produce antibodies again. And those, of course, those parent cells are the B cells. And when they stay around for a long time, we call them memory B cells. That phrase memory means that they go into lymph nodes, the B cells, they're in bone marrow, they're hiding out in your body, and then they're just ready to produce antibodies if they see the virus again.
Right. And so essentially what happens is something's picked up by other cells. It ends up in the lymph nodes. The B cells, hey, I've seen you before. Right?
Yes.
Forms the antibodies and starts that immune response saying, I know how to fight this. And because you've seen it once, the immune response is very quick compared to an initial sort of the first time you see something.
Yes. And not only is it really quick and they'll produce antibodies right away, but the interesting thing, and I think sometimes we forget about this when we talk about variants, is there was a January paper in Nature this year that showed us that if you get long-lasting memory B cells, their antibodies that they'll produce will adapt to whatever kind of variant that you see of the virus. So meaning if I see, now they're called gamma delta, but if I have a immune response against the alpha virus, and then a year from now I see the delta virus, those antibodies have gone away, but the memory B cells will come out, produce antibodies, and they'll actually be specific for that, the couple of mutational changes that Delta variant gave us. And I think that's so important because we keep on talking about boosters and do we need boosters, but our own body can do that for us, that these antibodies will be adapted.
Right. And I think that's an important point to focus that. It's sort of like seeing a dog and it looks different, but it's still a dog, right?
Yeah.
Maybe it's a golden retriever versus a black retriever or something like that. And your body's like, oh, I've seen something pretty close to this. And it's almost as if the system is designed anticipating that at some point things would change, right? The viruses mutate, pathogens change in our environment. And so our body changes in a reasonable manner, right? Along with those pathogens. And so
exactly right. That's why we don't call them different strains. We never say the word, this is a different strain because it's not it's not a cat because you had a dog. Right. It's not a different species. We call them variants because there's just some different spots on that dog.
Yeah. And I found it interesting listening to a discussion, I think it's on Twitter or another, where they're talking about how essentially in your body, we always talk about someone has the say B117 variant or something like for COVID, but my understanding is that within your body, you have that variant, but you have all sorts of different like mutations going on. You have millions of viral particles. And so, I mean, you're sort of like, evolution's kind of going on in your body, right? These things are changing. And so that may be the dominant strain, but you probably are seeing all different types of, different types of or variants of of coronavirus or whatever virus it might have, right?
Yes, that is a fair point too. That's actually really illustrated in HIV, where when you get HIV, we think that we see the dominant strain because we sequence it up from the bloodstream. But then when we call what's called deep sequencing, we can see that the HIV strain has a whole bunch of different mutations and there's different what we call quasi-species. And that's okay because that is natural. And actually that's what the virus does, but so does your immune system. At least with COVID, your immune system will adapt to those different, going back to your analogy, I see like Yorkshire Terriers and I see different terriers and different types of dogs, and you're able to produce immune responses against the different strains, the different variants.
Right. And so I guess when I think of the variants, my feeling was I guess similar to yours in that I was not super concerned about these. I think you can recognize the variants that yes, there are adaptations and changes in the virus that make it more likely to infect you, more likely to cause more severe or less severe symptoms. Those sort of things naturally evolve as the virus matures, I guess, through time. But it's essentially the same virus, right? I mean, so and then your body should still be able to mount an immune response. Although, would you say it's possible that, over time, let's say 10 years from now, it's changed enough that that you still get sick, but you just get maybe like an upper respiratory infection, like what you say, a common cold? Is that
yes?
You can kind of see coronavirus and get sick from it multiple times, the same strain, right? Like OC43 or whatever the other ones are.
Yes, the cold coronaviruses. I think that's a very fair point. And then that does make us, because everything that you said makes me want to talk about T cells. Can I talk about T cells?
Well, that was my next question. So launch into your T cell tirade.
Because when you said severe infection, I mean, that is what's so interesting about that second arm of the immune system. Okay, so T cells, get produced by either natural infection or the vaccination, but T cells are even more complex. And what I mean by that is the way you measure T cells are not by, it's not as simple as measuring antibodies. You usually use a flow cytometry machine and you can actually see all the different T cells that form against different parts of the virus. And interestingly, just across the spike protein of this coronavirus, there are probably 100 places across the spike protein that different T cells line up. Those are called epitopes, or little tiny bits of the spike protein, and they line up and they attack these different epitopes. And if there's 100 places around on just the spike protein alone, the Delta variant, which we talk a lot about, that now was B1617, has 13 mutations along the spike protein, but there's 100 different places that T cells line up. And the reason T cells are so important is they do protect you from severe infection. If say your antibody response has waned, because it will, and say you see a virus 10 years from now and it slips through your nose and you may get a mild upper respiratory tract infection, like you said, those T cells will still be there and we know that memory T cells are produced. So again, goes into the bank, these memory T cells, they'll still be there to protect you from severe infection, because what T cells do is they will attack this virus when it tries to get to your lungs, and they will prevent you from getting this horrible COVID illness, to get really sick. So I'm very secure in the fact that I think that our vaccines or natural infection will protect us against severe infection. And then, like you said, as the antibodies wane, if you can't produce them fast enough, you may get an upper respiratory tract infection in your nose before you can kick in that response.
Sure. And I mean, when people ask me in the hospital, wherever, they say, "Hey, do you think we're going to need boosters?" My response has always been, "I don't think so." The caveat is always, well, if you're elderly, there's a chance that you may not have produced enough of immune response or whatever, and so it might be reasonable to think, if you're an elderly person, that you might need a couple of booster shots, right? I mean, because your immune response, well, I mean, as you age, things just don't work as well as they did when you're younger, right? I mean, we all feel that every day. And so it wouldn't surprise me that you have the same sort of thing with your immune system, that maybe if you're 80, you might need a couple years, or who knows? I mean, I think it'll be hard to sort of determine that, except unless you let time pass to find out how people respond.
I agree with you that the kind of the equivalent is, I think about times where we say, if you're older, you're not going to have the best immune response, we're going to give you a higher dose of the flu vaccine, for instance. Like, right, we give double doses of the flu vaccine. With that idea that it's going to take a little bit more of a boost to get the same immune response in an older person. So that is true. I think immunocompromised patients or older people may need a booster, but it's time will tell, like you say, because if we're not seeing a lot of the virus, we'll have to decide if it's worth the effort, because we are seeing incredibly lowering of the virus, circulating in communities with vaccination.
Yeah, it's almost like we've walked off a cliff in the United States. I mean, we're obviously just going to focus on America because the rest of the world is in a different spot than where we are. Where every country or place is in a different spot, but certainly with our vaccination rates that we have, and the large numbers of natural immunity, you've got to figure we're approaching 70-80% of Americans probably have immunity to this pathogen at this point. I'm just guessing.
No, I think that's such an important point what you just said, because somehow this natural immunity is not getting into our calculations sometimes.
Right.
And so the paper will say, only 43% of people are vaccinated. And then that sounds so dismally low. But that doesn't account for the fact that natural immunity is a thing. I mean, if we didn't have natural immunity, we'd all be deceased by now, just from infections. I mean, we do mount immunity to pathogens that we've seen. And actually the immunology research on this virus shows really good immunity is developed with natural infection. So it is kind of an addition of both those things. And we don't know the exact number because we don't know the exact number of people who've been infected, but I think your calculation of 80% is right.
And that's the thing that's frustrating the most, is because I have a number of nurses who've been infected, and they're compelled to get vaccinated because of, either rules in the hospital put forth by the state or by the hospital, or, just you can't walk around without a mask because you've not been vaccinated. But they went through COVID, or they had it. I mean, they had documented proof that they cleared it 6 months ago, 3 months ago, whenever, and they're compelled to get the vaccine. And it doesn't make any sense to me why we're pushing that, because I feel like we've had a number of studies now that have pretty definitively shown that the immunity is at least as good, if not better, than it is with the vaccine, which is, I guess, not surprising. But it seems that I just don't understand why there's this push from the CDC and from government leaders, except that they can't quantify exactly how many people have immunity, right? Like, if people are vaccinated, I know exactly it's 48% or whatever, but it just seems it just saddens me, because I feel like we're putting people at risk when there's no benefit to it. And I will
tell you that it's the most frustrated response that I ever get to me on Twitter, for example, that people write and say, I know I don't have to get vaccinated because I've had natural immunity, and why am I treated like I have to?
Right.
And I think what you said is right, that part of it is because it's hard to document. Well, you'd think we could document natural infection, but it's harder. It's so easy to pull out that vaccine card and say,
sure.
I've had my 2 vaccines. And there's that aspect. And then unlike the world, because the World Health Organization, it would put out a document just 3 weeks ago that was very clearly laying out that natural immunity is likely to last for a long time. We haven't done that equivalent thing at the CDC. Somehow the CDC has not emulated the WHO in just acknowledging this fact that people who have natural immunity are likely immune. And you're right, I think that is leading to frustration. And I always think about public health trust during this time, because this is coming up for children as well, but vaccinating children, but we have to generate trust. Just say the facts. Likely natural immunity is going to last a long time, just like vaccination induced immunity. And if you say that facts, then people will trust you more.
Yeah, I find it all puzzling, except, there are political reasons to say we want vaccination rates at certain points, otherwise it's not successful. And maybe that's driving a lot of this. I just feel bad for the people who've had it, because I know people who have had COVID, definitely had it even like almost a year ago, got vaccinated, and they had horrible reactions. I mean, it was bag pitting edema and all sorts of other things, which, I mean, no.
I mean, I think
long-lasting
about
problems,
chicken pox. Like, I keep on thinking I had chicken pox as a child, because I'm like right at that spot.
Yeah.
I didn't have measles, so I'm like in between the ages. Like, I wasn't before 1965. But if I was born before 1965, we don't give measles shots, right? Like, that is just sort of like, as an infectious disease doctor, I check the age, and then I don't, because you assume everyone's had measles. And same with chicken pox. I've had chicken pox, so I was never offered, nor will anyone probably give me a VZV vaccine, because they know I have immunity from having measles, chickenpox as a child. And it's interesting because the one thing, and I know this is so geeky for me to say, but the coronavirus is an RNA virus that is a DNA virus wannabe. And I love saying that because I just think it's so geeky and funny, and it makes me laugh every time I say it. But what I mean by a DNA virus wannabe is coronaviruses don't mutate that fast. What I mean by that is that they actually have their polymerase, or the way they replicate, has a very strong proofreading mechanism. They don't like to make lots of mistakes like the influenza RNA virus polymerase, or the way it replicates, does. So it's likely that it's not going to keep on changing when we have low rates.
And so then let's talk about children, I guess, because that's where we are sort of in the process of the vaccination now. What are your opinions on children? Because I saw something that said that maybe a lot more kids have had it than we think. The magnitude, they're much more likely to be asymptomatic. Do you think do you think we're going to be vaccinating kids down to the age of 2 or 3? Or do you think this, I think it'll be available, but I guess the question is, where does it make sense when we're looking at risk benefit profiles, right? Because we don't, people ask me what the long-term risks are of the vaccine. I said, probably really small. It's hard to know. And honestly, if you're talking about long-term risks, like I could develop a PE 15 years from now, it'll be impossible to say, well, that's because I was vaccinated, 50, right? The a lot of the long-term effects we can't really know outside of ones that are, pretty early on. I would guess.
I agree with that. I mean, when I think about long-term effects of vaccines, which are actually very rare, I think about live vaccines. So those live attenuated vaccines, or like polio or live measles vaccines, 60 years later can revert and do something to your body and fundamentally give you like the actual infection. But that is very rare. I think this is not something that's going to give you long-term side effects. I think its side effects are going to be more short-term, like if you have a massive inflammation or something happens in the short term. And you're right, the risk versus benefit calculus does change in children, because children are not at risk for severe disease like adults are. And that's just a fact. That can't be politicized away. It's just a fact. They have much lower rates of severe disease. And so in a way, and this is that public health trust question, I feel like we could say very cleanly that we're probably going to vaccinate children to protect adults. I mean, that is something that's not historically unheard of. Pneumococcus vaccine for children actually is likely to protect our 60-year-olds who get pneumonia. Measles, mumps, rubella, diphtheria, pertussis are all mandated vaccines for children because those cause severe disease in children. And but these other vaccines, there are often we're vaccinating children to protect adults. And I feel like that has to be really clearly stated when we get in the public health realm, because there are parents that are saying, I can totally see through you that I know that children are less at risk. Just say it. Just if that's what we're trying to do by vaccinated children, we should just be able to say that. And I do think it's the risk benefit calculus then becomes different for children. And if there's side effects that are harmful in the short term for children, we have to acknowledge those and watch them carefully and really look in the clinical trials because they're going from 6 months to 11 years. I want to see that safety data. I don't want to assume that it's totally safe. I want to really see that safety data and then watch children get vaccinated and track carefully and make sure they're fine.
Yeah. Well, and when people ask me about the kids' vaccination, I'd say, well, it depends really on what you feel. If you feel like you can't feel safe going out in public, your kids are like anxious about not having the vaccine, then without a doubt, it makes sense to have them vaccinated because it's just make everyone feel better. I think overall the risk to either is probably super low. So you really you're not lose much by doing it. But if it gains something from you, your ability to be socialized or do whatever, then I think go ahead and do it. I just don't want people to feel compelled one way or the other.
I completely agree with that. Exactly. And that's why I don't think that they should be mandated for schools or mandated for camps or mandated for normal life. But there is no doubt, especially in my region, for example, that there's quite a bit of normal life will only be once you tell me that your child's been vaccinated. And, I did vaccinate my child, but I actually am waiting for the second dose.
Yeah. Okay. So you had the longest Tcell Twitter thread, I think, in the history of Twitter. Yeah, I think there's probably, I don't know how long it was.
I love that Tcell thread. I think about that a lot.
I mean, it was great. I have to admit, I couldn't read many of the study. I'm like, I just can't go through all these. But and you love the Tcell. It's clear that you love your.
I love the Tcell.
Anyone who said HIV is in the CD4 count, CD8, all that stuff, right? I totally get it. So, early on, it became pretty clear, and I think it's still probably evident that people have, for whatever reason they may have, they're just not susceptible to SARS-CoV-2. We're not quite sure why. And we think it's because they have some the reaction of T cells to the virus, even though they've never actually seen it. Right? We took blood samples from people 5 years ago, and they still actually responded as if it was an infection they recognized. So there must be some sort of cross reactivity with other viruses or other coronaviruses, perhaps. I mean, do you think that's the case, or is that why some people just seem to not get it or are asymptomatic for the most part?
I think that's a really excellent question, because I think there's two reasons. One is, of course, if you don't have a lot of receptors in your nose to even take in the virus, I think that would make you, that's why children are less susceptible to get it, even if they've been exposed, a threefold less likely to have it in their nose than adults, because they just don't have the ACE2 receptor in their nose. And then you're right that I think the T cells really is what makes you have asymptomatic infection. There was this excellent paper that showed that what is the difference between two people of the same age, same comorbidities. So you take that out of the equation and why one has severe disease and one doesn't. And essentially it showed it was the T cells. If you generate nice T cell responses for seeing the coronavirus, then that leads to more asymptomatic infection, going back to they really protect you from severe disease. And yes, I think that there was cross T cell reactivity to other coronaviruses, but likely not enough, meaning I think that was postulated way more in India, for example. And then what we saw recently in India was that it just simply isn't enough. So there's no doubt that there may be some cross reactivity, but it's not enough to protect you, and you really need SARS-CoV-2 specific T cells.
Okay. Yeah. And I mean, coronaviruses are super common in all sorts of mammals. I mean, every mammal has a bunch of them. We have, I guess we'll count this as our fifth endemic coronavirus, because
and there's SARS and MERS too. So now we have 7. I mean, those aren't endemic anymore. They went away, but yes, we've seen 7 coronaviruses.
Right. Yeah. So for me, putting on your epidemiological hat, if such a hat exists, would you, when you look at the different state policies, we'll just look at the United States again, it's hard to look at it and find that any policy really made a difference. from a lockdown standpoint, mask mandates, all these sorts of things. I mean, you can imagine in many ways that things would matter, like avoiding people, absolutely, because you're going to keep you from getting the virus and spreading it. I mean, there's no question about that. I probably wearing masks properly and avoiding people probably helps too, but it doesn't seem like any of these measures really made much of a difference. It just kind of moved randomly. I think, Michigan, we got hit with an extra wave that no one else got hit with recently. We're just kind of emerging from that. Us in Minnesota, oddly enough. And you even look at the border, it doesn't even go in Indiana. It's very strange. I don't quite understand a lot of this stuff. I don't understand with the virus, but do you feel like any of these things made a difference? Or do you think that we've sort of been spinning our wheels most of the time just because we felt like we had to do something?
This is an excellent question. And I think I've been thinking about it so much. I think you're right that, of course, good mask wearing that fit and filtered inside would have made a difference. But it's not like we did that, actually. We didn't even use the right masks in workers' environments, for example. We just said, wear any old cloth mask. So that didn't help like N95s would have, or filtered masks. And then on the other hand, the lockdowns, they were so disparate around the country and they didn't change outcomes in the sense that California had, and I know this because I live here, had the most stringent lockdowns of the entire 50 states. And we are just square in the middle in terms of the number of unfortunate cases and deaths. And we can never argue that away. We can never say that we had the best outcomes because we had the most stringent lockdowns. It's simply not true. And our businesses and schools and everything got really hurt. And the way that I think about any pathogen, and I think this is this kind of long view of infectious diseases, is the only way that gets you through it is immunity. It's just the true only thing. So going back to 1918, terrible influenza pandemic, which was frankly caused so many more deaths than we've seen from this, 50 million deaths, and now we're at 3.6 million deaths. 50 million deaths of influenza in 1918, we've at 3.6 million with SARS-CoV-2. It was a terrible pandemic, and there was no vaccine. There simply was not. And so and 1942 was our first influenza vaccine that was ever developed. So the only way to burn through it and to get it to go away was horrible, horrible deaths and natural immunity, and it did go away. And so here we're so lucky because we had natural immunity, which we didn't love that, but we had to, we didn't have a vaccine before. And now we have the vaccine, and adding that to natural immunity, this is what's going to make it go away. And that's why when people say, are we going to surge when we stop wearing masks in California? I keep on thinking, no, that immunity is your force field. That's the long view of infectious diseases. It's the only way things go away. So we will have to look back and say to ourselves, the places that were most stringent about lockdowns, can we please admit that it was hard? It was hard for schools. It was hard for businesses. And please be honest about that, because it didn't save us. It didn't save us, at least in California, it didn't.
Yeah. Well, and if you look at California too, it's a very young state from a population standpoint. And Florida was, I think they're about the equivalent. Of Florida's like one of the oldest states, not surprisingly. I mean, and yeah, from a death standpoint and hospitalizations, it's about the same, right? I mean, so that kind of gets into the next question, I guess. You mentioned earlier, you're talking about the mutation of coronavirus, and it tends to be fairly slow. And I'll use the term zoonotic, and so that means it starts in an animal, it moves to another animal, and gets to humans. So usually, what you have is, as far as I understand, is you have a coronavirus that we think pretty sure it's certain to start in a bat. And then usually what happens, like with the first SARS-CoV-1, it went to an intermediate animal. I think it's called the civet.
Palm civet specifically. And it's a very cute little cat-looking animal. Yes.
And then that made it into those wet markets. And then so you had this virus that had sort of adapted because the coronaviruses are specific for one mammal as far as like getting through the cells, right? And it then had made some sort of mutation that allowed it to get to another mammal. And then from there, it made it into humans, right? And what's been strange about this one, and we found that in a few months, they sort of determined the progress of what bat and then what, animal, and then where it entered. We've had 15 months of the worst pandemic in anyone's lifetime, and we have no shortage of people out there looking for an explanation. And we haven't found anything. I mean, we're fairly certain maybe what bat it came from, but outside, there's no intermediary. It seems very strange, especially when you look at, you say these coronaviruses generally kind of mutate slowly. You would think you'd find it in nature in some in its, intermediary area host, right?
Yeah, what is its intermediary host? I think that's a very good question, and it does lead back to what's been happening right now in the news. I mean, I think there's no doubt in my mind that it came from bats, because I think you can't create a virus out of nothing. You just can't.
Right.
I've never heard of it. So it did come out of bats. Okay, so then where did it go intermediary to get to humans? And that is odd that we haven't found it. And then, yes, of course, it's odd that it was being worked on in a lab in early November in the Wuhan Institute of Virology. That is strange, because what I keep on thinking about that and is, if we had just known the sequence earlier, we could have created vaccines earlier. And that is my biggest concern about this transparency questions that are coming up around the Wuhan Institute of Virology, or what was happening in China, is that I do want to understand the intermediary host, if there is one. I still think there's got to be one, but it's a good question. But what upsets me most about this transparency question is, I wanted to get to a vaccine sooner, because then it wouldn't have been November 2020 when the first candidate vaccine was produced. It could have been something like February or March, and then we would have been in a different situation.
Yeah. I mean, if nothing else, the vaccine has, to your point about the early pandemic, it was going to be 2 to 3 years for us to get the natural immunity to fight off, we'll call it, to end sort of the pandemic. The vaccine
with
is just
terrible suffering,
right, and the vaccine just short circuited that. Now it's not everywhere in the world, and so they're suffering from this as we speak.
Exactly.
So one of the things talked about in the news a lot is gain of function, which I admit I knew nothing about. I'm not a bench scientist and never have been. I went to medical school intended with the purpose of avoiding the bench in the laboratory. I always liked pathology, but I just couldn't. I just got headaches every time I used a microscope. So that career was over for me before
I actually started out MD PhD, little known fact, and the same thing that happened to me. I did 1 year of the PhD, and I was like, no, I want to go see patients. So I didn't finish the PhD.
Never finished the mud fud.
Yeah.
So the gain of function, to my understanding, is it's basically a way of inserting through various methods, and we'll just leave it at that, I guess, that to insert changes into the genetic profile, or the RNA in this case, or proteins in the virus itself, and to enhance its pathogenicity, so make its infectiousness or what it does as far as symptoms or whatever. And that's what they were doing at Wuhan. They took they have all the kinds of bad coronaviruses, and they were just experimenting with things because ostensibly it was in order to better understand how the next pandemic, a pandemic might occur, and how people might get infected and those sorts of things. But essentially they were potentially making, and we don't know if this actually leaked from the lab, which it might have, but we don't know at this point. But it certainly seems like a very dangerous practice. And I feel like the benefits from knowing how something really dangerous can can affect people, it's hard for me to understand why it's worth it, right? Like I was a nuclear engineer as an undergraduate. So it's very easy for me to look at fission, for instance, and say, well, yes, we can make nuclear weapons. However, we can use fission to create nuclear energy, right? Which is, great sort of benefit to lots of people. I don't see the large benefit to gain of function research where you potentially create super viruses, unless you're trying to make weapons, but that's not, I think, what anyone's contending.
I totally agree with this, because I go back to the history of smallpox, which is that, do you remember that after we eradicated smallpox, the only disease we've ever eradicated, there were 3 vials of smallpox in a US lab, in a UK lab, and in the former Soviet Union, and they were destroyed. And it was like, there was a question of like, well, what if we need this in the future to combat some super strain that someone makes as bioterrorism? And the danger was, no, you don't want dangerous viruses in a lab around, so that someone could do something bad to them and make them exactly what we just said, like make them have gain of function. So I don't like the idea of anyone doing anything with viruses that can make them dangerous. The other question about that is, for example, creating antimicrobial resistance. When the anthrax, that bioterrorism event happened in 2001, we thought, oh, remember those envelopes with powder? I mean, we thought, oh, you should be able to treat it with penicillin. You can always treat Bacillus anthracis with penicillin, but there was inserted plasmid and they actually needed ciprofloxacin. So no one should be fooling with viruses or bacteria to make them more dangerous. And so if that was what was going on, we got to shut down that kind of research.
Yeah, and to your point, that's the transparency question, right? That's the thing we want to know. I mean, and we actually have, it seems like there's a link to the United States as far as funding this sort of research. And I think I'd recommend you, there are plenty, I'll put a couple links in the show notes if people want to find out more about some science writing, which I think has been pretty good about people who advocated for gain of function testing, and they actually sort of squash the idea of that there's a transparency, which, to your point, I mean, I don't think it's important to point fingers outside of the fact that, if people are doing things that were unsafe or unwise, we should rethink what we're doing in lots of different labs, because without a doubt, no matter how careful you are, there's always a chance for accidents. And if you're not gaining much from it, you're only just putting people at risk. I mean, look at what's happened. I mean, there are millions of people have died from this and more.
I mean, the way I think of it is transparency in everything is the name of the game with this pandemic. So this relates back to what we were just talking about even earlier, that you have to just be, okay, so transparency has to be figured out here, what happened there. Then even in public health messaging, transparency about children's vaccines, that we're going to be doing this to protect adults because children have less disease. Just be transparent. And if it's safe, that we may want to do that, and that adults should be able to choose for their children. And then transparency about when we go back in time with this pandemic in the United States, where lockdowns were helpful and where they weren't. Like, all of this stuff is about transparency, right? And this entire pandemic, I can't even imagine how many history books are going to be written about this pandemic and transparency, because it was and continues to be, because I'm writing a piece tonight on global vaccine equity, and as soon as we get off the phone, I'm going to go back and it was due earlier today. But we have to get the world vaccinated now, because this disease is still raging. Like you said, it is terrible that India is just coming off. I mean, I have many relatives in India, and it's just coming off what just happened in India without vaccine. So I can't think of anything more important than to dissect fundamentally what happened with this pandemic in many ways, and ensure that we truly write something now that dangerous things don't happen in labs, and that also we respond to a pandemic appropriately. And there's just going to be so much that we learn from this, but learn from it in the hard way.
Yeah, well, that's usually how people learn things.
Yeah,
you like to learn from other people's mistakes. Unfortunately, this is one that affects everyone. Yeah, I think we're gonna. I almost look at the vaccine right now, much like in the beginning, just when we distributed the vaccine in the United States, there's a lot of debate on who gets a vaccine, right? Was it the elderly? Is it the healthcare workers, firefighters, those sorts of things? And I think looking back, Florida probably had it right in the sense that they said the elderly should get it first because they're the most susceptible.
vulnerable. Yeah.
And I feel like at this point with our country, it makes little sense to give small children the vaccine when we have people who are vulnerable all over the world. If we have a limited supply, I think, we need to think a little bit bigger than this country. And, whether you make them pay for it or whatever, I don't care. But I think it seems to me that if you have a limited supply, the best good is going to be done by giving it to other countries, because we're getting very little benefit in this country from giving it.
I wrote an article just called exactly that with two other authors in the Atlantic. It literally said American kids can wait. They titled it that, but that was our point, that healthcare workers around the world, if we just took those doses for our young children here and gave them right now to healthcare workers around the world, we would do so much good, because they're the ones that have to treat people in the hospital. And then we can come back, and when we have more vaccine supply, come back to the less vulnerable. So I completely agree with what you said.
Yeah, I think also when it comes to writing the history books, I think it's going to take a while before we can actually and hopefully nothing big happens before then, but hopefully we have time, because there are too many people with so much at stake with what happened, that they're not going to accept the fact that what they said or proclaimed was the wrong plan of attack or defense against this vaccine. And I think there are a lot of people who have things to answer for, and it's going to be hard to get to a good, appropriate response for a couple of years, just because I think it's too politically charged at this point, and people's
It's
careers
so
in the line, right?
Yeah, it is, but it has to be written clearly and cleanly and transparently, because God forbid we have another pandemic, but we have to have all of this written so that we're ready.
Yes, and hopefully it's long after I'm gone, but if it's not, hopefully it's far enough out so that we know sort of what to do.
Exactly.
So, Lenny, any moment of hope, the mRNA is a pretty fantastic vaccine, as far as we can tell. Yes, we don't know long-term effects, and but it seems by all accounts to be extremely safe and effective. How do you see it transforming infectious disease in the next 10 to 15 years? This technology.
Yeah, I mean, I'm extremely excited about this mRNA vaccine because, like you said, we actually had it since 2011. Interestingly, like the technology was developed around MERS, and then of course MERS went away really quickly. That second bad coronavirus that caused severe disease, and now I can imagine, or not even imagine, people are talking about a global flu vaccine that uses mRNA technology that doesn't have to be given every year because it's not against the spike protein. The two spike proteins, H and N, which change so quickly, create an mRNA vaccine that's around something more fundamental to the virus. And then HIV is very, very tempting here because we have tried for years unsuccessfully to create an HIV vaccine. Actually, HIV, malaria, and tuberculosis, there are models that show that if you even had a 50% effective vaccine, these are such prevalent infectious diseases that you would do a lot of good in terms of reducing new infections. So those three infections, I'm very interested in mRNA vaccine technology for them, especially HIV. We've just had a macaque study just recently that looked at an mRNA vaccine candidate for HIV already in macaques, and looked like it was working well, but it was 7 macaques. So we need to do more research than that.
Do you think current vaccines we have could be converted to mRNA vaccines as well, like measles, mumps, rubella, polio, those?
It's interesting because people even already have developed them, but then everyone was like, well, our polio is working fine, MMR is working fine. Well, I could imagine that now this is going to really generate interest, yes, in maybe upgrading our vaccines. I mean, I do think live vaccines, those are the ones that I could think of that would need upgrading, and that's MMR and polio.
Right. Well, in polio,
polio in certain cases, oral polio vaccine.
The oral polio, which is, I think, pretty much what they use most of the remote ports. I mean, that's kind of what they're using in the remote portions of the world where they're trying to eradicate polio, right? That's all.
Yes, ring vaccination to eradicate. And actually, there is an advantage to oral polio vaccine in these areas because you secrete it in the stool, and then that helps someone else get immunity. So these are complicated decisions to be made about mRNA vaccines, but the diseases we don't have vaccines for, I'm very interested in.
How did you find yourself in this position we are in tonight? Like, you're suddenly become a spokesperson for all this stuff. I mean, obviously, I'm guessing you didn't go to medical school. You didn't wake up in 2018 think, you know what I want to happen next year? I want to become an advocate I want to be the Tcell advocate.
I wish this hadn't happened so that I'd have to talk about Tcells. But it is weird. I mean, the way I think, for me, I love infectious diseases. I love the history of it. Like, I'm that person who reads those books about like cholera in 1854 in London and the pump, and like how we closed down society and then made the poor people do all the work for the rich people so that the poor people got sick from cholera. And it's all really about disparities. And that's of interest to me. And then I really was very interested in HIV, and that's really my main field, and I can't wait to go back to it. But then HIV makes you think about T cells. And so then I got to be think about T cells with COVID. I don't know what happened. I think I live in San Francisco, and we've had a very lockdown response here, which fundamentally has really hurt school children because our schools have been closed. And it's made me think of holistic and nuanced messaging, which is not exactly all my friends and family are doing. I mean, meaning I've had a lot of colleagues in infectious disease that maybe aren't thinking more holistically. I'm not sure why. Maybe it's what you said, that it seems to be like we all have to say the same thing right now with coronavirus, and I don't think that's right. So I don't know why I'm in this position, but I hope more. I thank you for interviewing me, and thank you for talking about T cells, because of you, I got to talk about them today.
Yeah, well, I think the first line for if you go to immunologists, like, can you explain immunology? Like, it's really complicated, right? Before I try and explain it. Well, thank you so much for being on the show. I really appreciate the discussion, and it makes me feel better. I feel more confident going to people, tell them, variants, not too worried about it. It's just, instead of a redhead, it's a blonde. We'll be okay. I'm not too worried about it.
I know I'm going to do your dog thing. I like that terrier. and the big Dalmatian, because they're all, I don't know, they're small or big, but anyway, the point is, yes, the same species.
Yeah. Well, thanks so much for being on The Paradox. I appreciate it.
Thank you.
Thanks for listening to The Paradox. If you like what the doc is doing, please subscribe and leave a review on iTunes or Stitcher. And share the show with your friends. Become a supporting listener to get access to special bonuses at patreon.com/theparadox. Show notes can be found at theparadox.com.